morning, good afternoon, good evening. My name is Eung Joon. In Korean terms, Yoo Eung Joon. I'm very pleased to see you and share the AI in terms of NVIDIA. So today I'm gonna present for the AI current and future in terms of NVIDIA. So I have a huge story for you. So some of you know about the AI, some of you not. It's okay to me. So during my presentation, if you have a question, then please let me know. Then I'm not sure when I reply to you, but I will reply to you for your clear understand. So today's agenda is I'm going to mention about the history of AI. So what is AI in the history, and then what is current status of AI, and what could be happening the AI in the future, right? So I'm working for NVIDIA for 5 years and 6 months now. So in terms of NVIDIA, I'm gonna present AI strategy and some technology. So and then I will share some reference with AI. So of course I attach some appendix for your reference. So I'm not sure if time is okay or not, but as you like, you can look at it, see the my slide deck and my presentation. Here is about 25 years, some big changes during 25 years in IT areas. So of course, many changes during last 30 years or 40 years, but I gotta mention about only 25 years. So many things happened during last 25 years in IT. Starting 1995, that was a big bang regarding IT. We call the PC Internet era. So at that time, the Intel, they are making hardware. Also Microsoft, they are making MS Office as software. So they jumped together and they they opened a new market. We call that the Internet. So with the PC Internet era, about 1 billion PC users, they can share their information together, right? That is a big bang in about 25 years ago. And then we move into 2000 and early 2000 and mid 2000. So there's two big things happen. One is cloud. I think most of you know about Amazon. We call the Amazon Web Service, AWS. They opened the cloud in early 2000, right? Guess what? They do kind of online book selling business at the time, right? So how can they think about cloud-based the business? So they kicked up their business in early 2000. At the similar time frame, we call the mobility. Mobility kicked up at that time. So with mobility, guess what? Even to me, I have my smartphone. I can use my smartphone for my work, including chatting, sending email, and some editing, etc., etc. Without mobility, I have very limitation for me to do my work, right? So, with mobile and cloud, the people, they can do their business, they work, what I call that, or beyond their capability, right? So that a big, second big bang in 2000. So during that time, guess what, what kind of the companies they get a benefit from those area, such as in Amazon. They are leading in cloud business nowadays. They spend more than 15 years in cloud business. They are dominant in cloud now. and then gets Azure and global cloud platform, which is our Google, right? Now the Oracle also they are kicking up their cloud business now, right? So those companies are leading the market for the cloud. Also, their market capital is pretty high, right? So that means the leading edge company, they have to invest their business in very early stage. Otherwise, they can't, right? And then move to the 2010, the year. Guess what? Many data happening, many data is occurring. So we call that the IoT, Internet of Things. So people think about what can we do with IoT? So there's a lot of the data. If we use those data for personal purpose or business purpose, so at the same time, one researcher from Canada, we call the Alex Krzyzewski, he work on some computer vision with the new way of analyzing, right? So like using deep learning. So they see the what about the computer vision using deep learning? So they did it. So the result is fantastic. So compared to legacy computer vision, using deep learning, they have more high accuracy for the performance. Since that time on, the deep learning could increase increase every year, right? So at that time, the Alex Krzyzewski, he used NVIDIA GPU for the deep learning, right? So that's the some triggering tipping point for NVIDIA, who can be big core the company of AI, right? And so I think that is 25 years the IT Big Bang. So nowadays we call it's 2021 now. So many companies in a big market share in IT, we call it Big Bang Ma. Big Bang Ma stands for Baidu, Alibaba, Tencent, Facebook, Apple, Netflix, Google, Microsoft, etc., etc. So those companies, the market capital is pretty big. So I attached, the NVIDIA stock, right? So, my company for the last 5 years, it was only less than around $10, right? Nowadays it's over 300. It's about 30 times growth for the last 5 years. So that means if one company they invest in early days with some kind of leading edge technology, later on their market capital could be big, right? So those things, make us understanding, the company, they should be very alert. They should invest very early stage, right? So there's three core factors for us to make success in AI, right? AI, they started about more than 60 years. Then why AI now? That we can leverage AI for the core business, right? There's three factors for AI to be successful. One is data, right? So to make the business success with the AI, then we need data. As the company has data by themselves, that is one essential for their company to do business with AI, right? So it looks like the oil in first revolutionized era, right? So One is data. Second is the algorithm. So as I mentioned, before, so in 2012, the researcher Alex Krzyzewski, he used the deep learning rather than traditional computer vision to see the object, right? So accordingly, the result of using deep learning is more than the 70% or 80%. So system time on, the research, they accordingly used deep learning for the analyzing object, right? So the second item for AI to be successful is algorithm. Okay. Third one, okay, we have huge data, and we have program to run those data. Now, what is the third element? That is a processing unit. We call the GPU, right? So without the GPU, how can you run your own application with much data, right? So we need a processing unit called a GPU. That's why NVIDIA is the core company in AI era, right? So again, three factors for AI to be successful. One is data, second is program, third one is processing unit, that is GPU. But I say one more thing, is people. So how come your company has data, your company has good program, and now you purchase a lot of GPU from NVIDIA? That's all? No. You have to develop your own people to learn or develop or manage those applications, right? So I add one more element, that is people. So whenever I go to the major AI graduate university in Korea, so there are over 10 AI related graduate school in Korea. So I mentioned, please increase the number of AI people in your school, in your university, in your college, right? Otherwise, in Korea, we cannot, expect a lot of good, growth leveraging AI. So that's my things, right? So again, people very, very important for AI to be successful. So why GPU is a major, big element in AI era? Guess what? Why the people cannot use a CPU in AI era? Of course, somewhat. But, you can see the slide for this. There's, Moore, Dr. Moore. He worked for Intel in late 60. So he invented one theory, that is Moore's theory, Moore's law. So every 18 months, through total system performance could be twice, right? So that has been true until 2010. But due to many factors, including transistor size, etc., no more the Moore's law could be true. So then what else? A lot of IoT data in 2010, right? So we need some solution from other areas, right? So NVIDIA over there, right? NVIDIA GPU, that is a parallel processing unit. We can backfill or fulfill or increment the accelerating your computing, right? So since 2010, our CEO, Jensen, we commit by the 2025, we can make more than 1,000 times faster than CPU by 2025. Yes, it's working now. It's on track now. So that is very important. So GPU is a critical element in this AI era. So, but at the same time, we need some software. Hardware is not enough for AI, so we need good, the operating system and library and some algorithm, even applications. So we call that full stack optimization, right? So we NVIDIA, we work on the library. We call that CUDA. Also, many enterprise customers, vendors, they are developing and work on their own algorithms. So we made some the SDK, we call software development kit, for the each vertical, and provide the each customers are based on open platform, right? So with that, we can accelerate the total performance. Okay. Now I'm gonna share new computing model and law, right? So I already mentioned about Moore's law has been ended, right? So now GPU is a crucial element for acceleration. So that's not enough, right? I'm going to mention about the accelerating computing. So to do acceleration computing, we need a full stack computing, right? So that means from hardware, and then library, and algorithm, framework, and then application. All stack should be optimized together. Otherwise, total performance could not be optimized. Second, AI has a lot of the different role in the world, like computer vision, voice, streaming, or conversation, etc. So each area they have their own application, own frameworks. So the AI could touch those model differently, right? Third one is due to some big data and parameters, like the last year, the Google they announced about GPT-3 that has around 175 billion parameter model, right? So to run those kind of application, we need a bunch of big supercomputer, right? So not just single unit component system, but also the big data center level scale powered computing, right? So we call that data center scale, the computing power. So to do what called the AI acceleration, one is full stack optimization. Second is we have to manage multi different AI model. Third one is we need work on for the data center level scale performance. Sorry for this is Korean, but I will mention it in English. So nowadays, AI application, we are reforming, we are transforming all business. For example, in data center, right? So we do training and inference. So we can do customer service or recommender system or process automation using training and inference. In edge AI inference, we can leverage a smart hospital, smart city, or retail, or 5G, or VRAN, etc., etc. And for the data analytics and machine learning, we can do kind of data preparation, prediction, and forecast, and some we check for abnormal detection, data visualization, etc., etc. And then professional visualization, we can do some virtual workstation, rendering, design, or visualization, etc., etc. And last, remote collaboration. We can one the source of the result or source of truth, and real-time simulation, etc., etc. Right. So in nowadays, most of the application should be based on AI. Otherwise, they cannot do transforming or renovate, right, their business. So this is fundamental. How the science application can be accelerated. We cannot do only CPU. We cannot do only GPU. So we have to use CPU and GPU together, right? So think about the legacy application. So application come from A to Z sequentially. That is legacy way for programmers to develop their program. In AI era, we can. So we accelerate core area. That is many CPU compute instance per function using GPU. So let's see about 5% of the total code. But using a GPU, we can accelerate total application more than 10 times or 100 times, etc., etc. So that's the way of AI is working now. So not like a legacy AI code, AI application code. AI is kind of the training and inference, unlimited repetition, right? So we gather a lot of data and put some labeling and do training and then simulation. After that, we can inference, right? After inference, the data we do inference, then back into training. So with those cycle unlimitedly, then the program could be accurate or improved a lot, right? So that's the way AI is working. So AI is a far different compared to our legacy application. Okay. So have you ever heard about Cambrian explosion? Human space is exploded in Cambrian period, right? So nowadays, AI model, we have a big bang in AI model according to own application such as conversational networks. It's very legacy and recurrent networks and transformer. That is a hot topic these days because that is convolutional AI, right? So BERT, Megatron, etc., etc. And then GAN model, generative adversary networks. So you guys have your own phase. Using our GAN model, you can adjust according to age, according to environment, etc. So that GAN model is very good. And later on, I recommend you refer to GAN model. And then reinforced learning and new species, etc. So many AI models these days, right? According to their own application. So we call that, the Cambrian explosion of AI models. Enabling enterprise transforming with AI, right? So we NVIDIA, we provide our own, platform. We call that platform to the customers for them to develop AI very efficiently. So for example, the conversational AI, we call Jarvis, but now we changed the Jarvis into Rima. So, conversational AI became very famous these days because even in Korea, we have our own language, Korean, right? So GPT-3 is developed by majorly English, more than 95%. So in Korea, we need our own some conversational AI. So our Korea, the Korea domestic company such as Naver, they are developing Korean language based conversational AI using our DGX SuperPod, which is a big AI system for the researcher to develop AI, right? So that is hot, at the SDK these days. And then we use Marine as for the recommender system. So Marine is SDK, which is made by NVIDIA for recommender system. And Metropolis, that is for smart city, very famous, very used in China now for the Metropolis SDK. And then for the healthcare, we developed Clara. Clara is platform for healthcare. So in US, majorly US, they are using our Clara platform for healthcare. And then like Korea, Japan, and Taiwan, we have a lot of manufacturing company, manufacturing factory also. So we can use Isaac for robotics. So Isaac is platform for robotics. And then many car company, they are developing autonomous vehicle. So for example, we are working with bench for autonomous vehicle using our Drive platform. The Drive platform is for the platform for autonomous vehicle. And then for the telecom, now we are in 5G era, right? So we invented area that is platform for 5G in telco area. So all those platforms could be they can leverage our hardware. So they can develop our platform based on desktop or data center or cloud, etc., etc. This is the end-to-end software stack for our development. So you can see left-hand side. You see very different framework model, right? So like computer vision, speech, recommender, or GAN. Those are very different, right? So for those applications, we do data. We need the data. We do training, right? So to training more efficiently, we developed TLT, Transfer Learning Toolkit. So using Transfer Learning Toolkit, we can training more efficiently, and then put into inference, right? So to do inference more efficiently, we use TensorRT. So these processes can be worked one by one. The application model, like the computer vision, speech, recommender, and GAN, right? So we need managing a different type of model. So we developed Triton Inference Server. So using Triton Inference Server, we can manage many various AI model, real time like the performance, right? So this is the full end-to-end stack for NVIDIA from training and inference. NVIDIA, you think about NVIDIA, what NVIDIA is. The NVIDIA is AI computing platform company. What does this mean? Okay, NVIDIA, we are 28 years old company, very young, right? So guess what? 28 years old, they are making some trial error, better energetic, good vision for the future, etc., etc. So AI computing, right? So AI computing very important. More important thing is the platform. We provide a platform for companies, AI companies, develop very efficiently. So I already mentioned about some platform such as Clara for the healthcare, Isaac for the robotics, and Metropolis for smart city, and Rima for conversational AI, etc., etc. Those are platforms for NVIDIA develop for AI companies. That's we call NVIDIA is a AI computing platform companies. We are the 21,000 employees now. Our headquarters located in Santa Clara. So among 21,000 people, more than 17,000, they are AI-related engineer. I'm business, kind of, operation and sales guys in NVIDIA. So the people like me is less than, 3,000, right? So NVIDIA is a AI, what I call that, engineer company, right? So we are four things we do, right? So one is we do three business. One is graphic. So, NVIDIA is invented for gaming graphic in 1993, right? So later on, we work in a workstation. So the graphics, the number one, the business area. Second is HPC, high performance computing. So since we scout many parallel computing engineers from Stanford University in mid 2000, right? So we engaged in some, high performance computing, right? Nowadays, more than, I guess, 80% of supercomputing, they are using our NVIDIA, GPU. So third one is AI, right? So that is a hot topic, that is the big, the agenda, right, these days, right? So NVIDIA, of course, we are engaged in AI, right? But one thing we have to mention about, our architecture, that is we are unified, accelerated architecture. So whatever the guys, they develop, graphic or high performance computing or machine learning or deep learning or data analytics, yes, architecture is unified. So one guys who work for machine learning, they move into graphics. Doesn't matter because, architecture is unified, right? That's very important for three business unit, right? Second is a full stack company. So I already mentioned about full stack is from hardware, chip and system, and then system library. So we call the CUDA. On CUDA, there's a lot of frameworks, right? Frameworks. Many enterprise customers, they are making their own frameworks. You know why? Because the customer, they use their own framework, then they rely on to their companies, right? So enterprise customers, they develop many different types of frameworks for attracting their own customers. So we are working on each layer of a stack. So we call it the full stack company. Third one is we work for the data center scale company. So these days, without data center level power, we cannot run AI application. So for example, in our data center, we call it Selene. We have a huge DGX system. So we run Selene to some big application such as GPT-3, like that, right? So nowadays we need a data center scale companies. Of course, in Korea, some companies like Samsung and Naver and Hyundai Motors company, SK Telecom, KT, those companies, they are using the data center level computing power to run their own application, right? Last one is open computing platform. So open computing platform means, so we developed framework. We developed some the SDK based on open platform. So customer, they can modify their application, their platform as like they want, right? So that is very important. So again, repeat, 4 things for NVIDIA doing. One is a unified architecture. Second is we are a full tech company. Third one is we are working for data center scale company. Last is an open platform. So tech customer, they can leverage our platform very openly, right? So did this repeat for me to what I call that, what NVIDIA, right? So we are 28 years in accelerating computing, right? So 2 years ago we acquired Mellanox, which is a network specific company. So now we developed a DPU, data processing unit, based on Mellanox, and then about 6 months ago we announced to acquire ARM, right? So we got somewhat challenging, but we are still working on. So after we finish the acquisition of ARM, then we will work on a CPU optimization also. So we speed up with the exafactors for the GPU, GPU, and CPU. And then again, we work on the full stack. So starting system, network, library, and framework, etc., etc. Third, data center level scale. So not just one system, one company, but whole multiple systems together, right? So, but we have to remember is we are one unified architect, one architect. So our engineer, they can work on gaming, and then move into automotive vehicle, etc., etc., right? So that is very versatile, efficient for us, right? This slide is a summary. NVIDIA for last 28 years ago working on. We worked based on gaming, right? So since that time on, we developed a lot of frameworks, including CAD, broadcast, medical image, life science, and physical science, quantums, genomes, digital twins, everything's right. So, NVIDIA, we are moving very fast. We are moving into various areas. We touch every vertical nowadays, right? So you can see our left hand, the chart. So we are full stack company, right? We are working on 3 chips: CPU, GPU, and DPU. We are working on a data center scale company. Around 30 million is CUDA we already downloaded. And we developed 150 SDKs. We kind of solved for 100 trillion industry nowadays, right? So it's so huge. So at this moment, I want to share some video. We call that I am AI, so which is mentioned by our CEO Jensen at the GTC, right? So it's 2 minutes and 30 seconds. So gentlemen and ladies, gentlemen, please watch this video. So you can see about 10 company or research who developed, the AI application. So you can see the name of the company or research at the left-hand side, bottom left-hand side. So
finding a path through Earth's frozen
yes,
expanse.
Canadian, National Research Council for them.
And peering into
This is for the MPS from University of Oxford.
of water on the moon. I am a guardian, watching for signs of pollution from the sky and protecting us from danger here on Earth. I am a visionary, learning from the past.
So we are working for the high performance computing. since
Better predict the
1950, right? We are using a lot of data
and keep us
to
safe
forecast
for
climate.
generations to come. I am a helper, keeping our most valuable
Now
species
we are working for agriculture for the using AI also, right? So I think this application could be adapted in some area in Korea also.
I am a healer.
So
Making our
healthcare
hospitals
it is
smarter
very
for the
famous
future.
in US, also in China.
And unneeded
Now
treatments
even in
are things
Korea,
of the past.
with some companies such as Luna, Bino, they are very famous for the healthcare using our cloud
I
platform.
am a creator, opening new paths to innovation. And new forms of artistic expression. I am a storyteller.
Also these days, the conversational AI that is very important. Even you guys, you are Iranian, right? So you can speak Iranian. Then if you said into Korean, then automatically translate into Korean.
I am AI, brought to life by NVIDIA. Deep learning and brilliant minds everywhere.
You see the I am AI, right? So what do you think about watching I am AI? So let me tell a bit about my first son. He's studying in U.S. He majored in computer music composition in Korea. Now he is studying continuously in U.S. So as father, and the NVIDIA, right? So I'm AI expert, right? So I proposed my first son. So why don't you learn and study AI with combined with your music composition? So because I watched I Am AI. So in the last scene of I Am AI, is that music made by AI, right? So in the future, I think all of business they are hybrid. That means single business cannot be successful by themselves. So even when it comes to the music composition, right? So music composition should combine with AI, right? So my first son thought about very sincerely. Now son is studying AI together, right? So whatever their job you have nowadays, you have to learn AI. You have to AI in your own area, right? So accordingly, NVIDIA, we are working each vertical to develop our own SDK for your purpose. So starting gaming, CAD, recommender, robotics, omniverse, betaverse, EDA, and quantum, even quantum, 5G in telco area, speed, computer visions, every area. So according to your specialty, according to your vertical, please think about what can I apply, the AI in my area, right? So that is my recommendation and advice for you guys, in the future, right? Okay. Thank you. So in the next chapter, I will mention about the more detail for the frameworks and some reference and use case, etc., etc. So see you soon. Thank you.